So before we do an example where we find the entire area of a regular polygon, I just want to practice finding some angles. So there's a lot already drawn on here, like BF and AF, those radii, and apothem FG. But if those aren't drawn for you, and a lot of times they won't be, the first thing you should do when you're finding the area of a regular polygon, whether it's a pentagon or a decagon or any type, is to draw the radiuses. So go from the center of the pentagon and go to each vertex of the pentagon or the polygon. Alright, and that divides it into triangles. Now all those triangles are congruent because all of these are radiuses and it's a regular polygon, so all of these sides are congruent. So by side, 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 all 5 of those triangles are congruent. Okay, then we could take that idea and use CPCTC to see that all 5 of those angles are congruent, and then make a full circle. So if we divide 360 by 5, we get that each of these angles are 72 degrees. So that's going to be the measure of angle AFB, 72 degrees. Then AFG, well, we talked about it in the last example. AFG is this angle right here, and that's just going to be half of 72 degrees because this triangle, which I'll highlight in red right now, is isosceles. And when you draw the height in an isosceles triangle, it's going to split it into 2 congruent right triangles. So each of these angles are going to be congruent, and they'll be 36 degrees. Then to find this base angle here, it's just going to be the complement of 36 degrees, so 54 degrees, because we have a right triangle, and one of the angles are 90, so the other two have to add up to 90. So GAF would be 54 degrees. And with those angles, if you just know one length in this entire picture, you can find all the other lengths, and then use what you know about area to find the area of the whole pentagon. So let's do it right now. So here's a decagon, right? If you didn't know that a decagon had 10 sides, then you could just count the number of sides. And it's regular, so we can assume all of these sides are 7 units long. First thing we're going to do is divide this decagon into congruent triangles. So any regular polygon you can inscribe in a circle, and all these purple lines I'm drawing would be the radius. And it divides the pentagon into 10 congruent triangles that all look like this. So once we find the area of this triangle, we're just going to multiply it by 10, and that's going to be the whole area of the decagon. Now, these 10 angles are all congruent because all 10 of those triangles are congruent. And again, that's because all these triangles have these lengths that are all radiuses, so they're equal, and then all the bases are equal too. So by side, 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 all those triangles are congruent. Which means that each of these base angles have to be 36 degrees because they make a full circle, so 360, and there's 10 of them, and they're equal, so 360 divided by 10 is 36. Which means if I were to split that in half to help me find the height, which is what I need to find the area of a triangle, now I create 2 18-degree angles. And then, because their angles have to add up to 180, each of these angles are 72 degrees, which you don't even really need to know, but it helps. So now, to find the area of that triangle, we have to find the height. So I'm going to do SOHCAHTOA, and I'm going to use tangent because whether I'm looking at 18 or 72 degrees, so if I'm looking at 18, I know the opposite leg, and I'm looking for the adjacent leg. If I'm looking at 72, I'm looking for the opposite leg, and I'm given the adjacent leg. Either way, O and A means tangent, TOA, SOHCAHTOA. So I'm going to do the tangent of 72 is equal to h over 3.5. You could have also said the tangent of 18 is equal to 3.5 over h. I like to have my variable in the numerator though, because then when you cross multiply, you just get h times 1, and so you have h already alone, and now we just have to do the tangent of 72 times 35. So if I type that in my calculator, I get that the tangent of 72 times 3.5, not 35, is going to be 10.77. So, in conclusion, I'm just going to find the area of this triangle, which would be the base, 7, times 10.77 divided by 2, and then take that number and multiply it by 10. So this area of the triangle comes out to be 37 square units, 37.7, and there's 10 of them. So when I multiply it by 10, I get that the area of the whole decagon would be about 377 square units.